Welcome, fellow curious minds, to a tale as old as time, yet as fresh as tonight's storm. A tale of shimmering, elusive orbs that dance in the air, baffling scientists and enchanting all who witness them. We're talking about ball lightning, nature's most enigmatic light show.
Hello, Curious Clan. Welcome, or welcome back. Let's get in.
Imagine a sphere of pure light, hovering, drifting, sometimes even passing through walls, not a flash, like regular lightning, but a persistent, glowing globe. For centuries, these luminous spheres have appeared during thunderstorms, like ethereal ghosts of electricity, leaving behind a trail of wonder and unanswered questions. What are they? Are they just tricks of the light, figments of an overactive imagination, or something far more profound? Since ancient times, people have reported seeing these fiery balls. The 6th century historian Gregory of Tours described a great ball of fire during a rainstorm. Fast forward to 1638, and a great ball of fire supposedly entered a church window in Devonshire during Sunday services, causing quite a stir. Even Russian Tsar Nicholas II, as a young man, claimed to have seen one. Have you ever witnessed a phenomenon that defied explanation? If you gather all the eyewitness accounts, you'd think ball lightning loves to play dress-up. Most describe it as a sphere. Sizes vary wildly, from a small grapefruit to a soccer ball. But then, you hear truly wild tales, like one the size of a truck tire. Or even, incredibly, a 100-meter diameter ball, seen in the Australian outback. Though, that last one might be something else entirely. And the colors. A rainbow of light. Red, orange, yellow, white, blue, even purple or green. It's often compared to the glow of a simple light bulb. But here's where it gets truly fascinating. A 2014 observation, captured by instruments, not just human eyes, showed a ball lightning initially appearing as a powerful purple-white, then gracefully shifting to orange, then white, and finally red as it faded away. These glowing orbs don't just sit still. They drift smoothly, often horizontally, but can also zoom up and down, spinning as they go. Imagine a ball of light gracefully floating the entire length of an aircraft cabin aisle. And perhaps the most mind-boggling characteristic, their reported ability to pass through solid objects, walls, windows, even down chimneys, leaving no trace. Try explaining that with our current understanding of physics. Most ball lightning encounters are fleeting, lasting only a few seconds, perhaps up to 10. But some truly remarkable accounts speak of them persisting for tens of minutes, or even over a minute. They often come with a soft hissing sound and a distinct, sometimes sulfuric, odor. And their exit, it can be a quiet, silent fade, or a dramatic, explosive pop. You usually see them near the ground, during thunderstorms, often right after a cloud-to-ground lightning strike. Some even suggest they prefer the dry phase of a storm before the rain begins, almost as if moisture bothers them. The sheer variability of these observations is a big headache for scientists trying to pin down a definition. It's hard to say what's typical when every account is so unique. What do you think causes such a wide range of reported characteristics for a single phenomenon? In our quest to understand ball lightning, it's vital to know what it isn't. It's not the split-second flash of regular lightning, that rapid electrical discharge we all know, and it's certainly not St. Elmo's fire, that steady, ethereal blue or violet glow you sometimes see on ship masts or airplane wingtips during a storm. St. Elmo's fire is like a gentle, localized hum of electricity, whereas ball lightning is a free-floating entity. Then there are sprites, those massive reddish-orange electrical discharges that dance high above thunderstorms. Think of them as giant, cold, plasma phenomena, akin to a fluorescent tube. Ball lightning, by contrast, is a low-altitude phenomenon, a single, self-contained entity. And finally, let's not confuse it with the willow. The wisp, those faint, flickering ghost lights, often seen over bogs and swamps. Those are usually caused by the oxidation of organic gases from decaying matter, a chemical process, not an electrical one linked to thunderstorms. Each of these luminous phenomena has its own unique story and scientific explanation. So, if it's not any of those, what could it be? Scientists have been brainstorming for centuries, and they've come up with some truly fascinating ideas. Many believe ball lightning is a form of plasma, an ionized gas. Imagine a tiny plasma bubble, a vortex of superheated, charged particles. This could explain its glow and its mysterious stability. Some even suggest these microplasma parcels might separate and regroup, allowing them to pass through loose structures like glass. But perhaps the most compelling idea, bolstered by recent evidence, is the vaporized silicon hypothesis, sometimes affectionately called the dirt clod hypothesis. This theory suggests that when lightning strikes the Earth, it vaporizes silica, silicon dioxide, from the soil. This silicon then reoxidizes in the air, producing the glowing orb. And here's the kicker. In 2014, Chinese researchers recorded the first ever spectrum of natural ball lightning in the wild. And guess what they found? The unmistakable presence of silicon, iron, and calcium. Exactly what you'd expect from vaporized soil. This was a monumental leap, finally providing some hard, instrumental data for this elusive phenomenon. Other theories lean into electromagnetism. Could ball lightning be a form of trapped radiation, electromagnetic energy bouncing within an invisible cage of forces, or perhaps a detached St. Elmo's fire, a free-floating ball of ionized air that amplifies the ambient electric field? Then there are the chemical combustion hypotheses, suggesting it's a chemical reaction involving atmospheric gases, or perhaps some unknown fulminate matter. This could explain those reported sulfuric odors. However, these models struggled to explain how ball lightning could pass through solid objects. And finally, some of the more complex core shell models propose a multi-layered structure, perhaps a positively charged core, surrounded by a rotating shell of electrons and polarized water molecules. This could explain its surprising stability and incredibly high energy density, enough energy to boil a significant amount of water. Which of these scientific hypotheses do you find most compelling, and why? Scientists desperately want to create ball lightning in a lab to truly understand it, but it's like trying to catch a ghost. While they've had some partial successes, producing small, luminous balls of silicon plasma that last for a few seconds, they haven't been able to replicate the full range of natural ball lightning's behaviors. Their lab-generated balls often rise like hot plasma and swirl as they lose energy, but they don't hover or move laterally, and certainly don't pass through walls. The big challenge. Lab-generated balls last for just milliseconds, maybe half a second. Natural ball lightning can persist for seconds, even minutes. This gap highlights the immense complexity of the atmospheric conditions and energy dynamics required to produce the real deal. What do you think are the biggest challenges in replicating rare natural phenomena in a controlled laboratory setting? While beautiful, encounters with ball lightning can be dangerous, even fatal. It can strike living beings, causing severe burns. Some speculate it emits high-frequency radio waves, capable of causing internal heating and muscle rupture. There are even theories, though highly speculative, that ball lightning might be linked to the eerie phenomenon of spontaneous human combustion. Ball lightning remains one of the most intriguing and enduring scientific challenges, a true unsolved problem in atmospheric physics. But with breakthroughs like the 2014 spectral data and compelling new video evidence, like the one from Alberta in 2025, we're finally moving from anecdotal evidence to quantifiable data. The pursuit of ball lightning is more than just academic curiosity. If we could understand its secrets, especially its remarkable energy storage mechanisms, it could revolutionize energy technology, offering ultra-high density, near lossless energy storage. Imagine a world where we could harness such power. So, The next time a thunderstorm rolls in, and you see a flash of lightning, remember the enigmatic orbs that might be dancing in the air. Ball lightning. A persistent challenge, a profound mystery, and a beacon of potential discovery, beckoning us to unravel its elusive truths. What other natural mysteries do you think hold the key to our future? If this video satisfied your curiosity, subscribe, like, and hype. Share the curiosity with your friends and family. Stay curious. Curious Clan.